Good later morning. Hello, everybody. We are going to do the Let's Build session, SQL-on-FHIR. This is a quick labs. For those of you who are not familiar, it's a training platform that Google has that helps people learn how to do all kinds of different things in the Google environment. And this particular lab is going to take us through a full exercise of demonstrating how to get some FHIR data into the system, how to create some of the various FHIR resources in the GCP environment, how to get that pre-created FHIR data from GCS, the cloud storage, object storage, into the FHIR store, and then from the FHIR store to BigQuery. So you're more than happy to play with that data. It's a small data set because we have limited time here. Once you get to that step and we get into some of the queries, I switch in a larger data set so you can see what that looks like. I think the data set we're using is about 20,000 patients, just to have something to play with. And I've also got in this tutorial just a bunch of queries that we reviewed in the last session, but it's really great to be able to have a chance to actually put them into the database itself and execute them and then be able to manipulate them. So I'm here. I'm available to answer questions as you go through this. Please just raise your hand. I'll keep an eye out, not from the stage because these lights are blinding me. And then maybe what I'll do is I'll actually pull up the tutorial on the screen and I'll kind of step through it and speak a little bit to it as we move forward. So if you haven't already, please fill out those links, send the email into the system, and then my colleague Vivian will help get you set up in the Quick Labs environment, and then you just log into Quick Labs and you should be able to execute this tutorial. Any questions, please? It's a classroom.
Yeah, so when you're on your home screen of Quick Labs, it will show up as SQL-on-FHIR as a classroom. I think it's under What's New. You should be able to click into that and then say Open Lab and Start Lab. And if you're not seeing that, raise your hand and I'll come help you.
Vivian, everybody. Thank you, Vivian. Okay. And yeah, questions? No? Yeah.
We just do that on our own, or because
Oh
we're
yeah.
already in there.
Oh, skip.
Yeah.
You can skip the video and.
Video.
Yeah, and this is a self-paced lab here, guys. Enjoy. It basically steps us through some of my talk, some of the queries that I showed in my talk, and starts a little bit earlier in the conversation. Like I said, being able to, take you through some of the command lines and some of the console and GCP environment. And if you were looking to do something like this on your own, you'll get some of that knowledge here on how to play with this on your own time. Thank you. No, the video is, this is what we're doing in Quick Labs. It's a product called Quick Labs.
Okay, so we don't have to.
You don't have to watch the video.
I still understand. Okay, thank you.
No problem. I know. Right. That's always how it works. Yes. Do you know what this error? Is everybody going to have this error?
Are you in, it looks like you're in a different
Oh,
account. You have to sign into your Quick Labs account.
yeah.
So
So once you sent your email and you've logged into explorer.quicklabs.com, you should see the lab there on your screen that you can click on. If you don't see the lab, put up your hand so we can come and help you.
Yeah, when you start the Quick Lab will give you your own username and password for that session. So when you click the button that says log into the Google console, use that username and password. So that's why I mentioned use an incognito browser or a private browser so that you don't have a collision. You might be logged in to Google with one of your other usernames. Yeah, and so what Quick Labs does is it creates your own session in the GCP environment and allows you to execute on whatever you need to execute on in your own environment.
Sasha,
Yes.
do you want people just to start diving into the lab real quick?
Yeah. When you get started, is everybody at this step in the lab? Once you get in to Quick Labs, you should see this document. And it starts off with a brief overview on what we're working on here. It's basically GCP. And like I said, it's going to step you through how to get some sample data into the FHIR API specifically. I don't want to step ahead, but we'll assume everybody's logged in. This uses the Cloud Shell and some console UIs, some Cloud Shell kind of interwoven, a little bit of each, to kind of give you a flavor of how you can operate with the GCP environment. So we highlight a couple of environment variables that you would enter in through the shell, and these will be used in subsequent sections as you're moving data around the system. Particularly interesting thing here, because we are in Europe, is when you select the region. So I've selected here particular Europe West 2 to operate in because it's in Europe. And there are other options there as well, and I think I have a link somewhere in this document that talks about regionalization and understanding like which resources are available in which regions. Particularly, the healthcare API is available in certain regions. So one of the first things you need to do early on in this tutorial is basically enable the healthcare API in your environment. So Google Cloud has many different products, many different APIs, and depending on your use case and whatever your project you happen to be working on, you generally have to enable each API specifically for use, and that's the case with the healthcare API. And we're going to use the console to create the data sets and the data stores The data set and the data store are the organizational hierarchy for example, in the information architecture on how you're going to store your healthcare-related data in the cloud. Data sets can have multiple data stores, and the data stores can be of multiple types. So you can have multiple FHIR stores, you can have multiple HL7 v2 stores, and you can have multiple DICOM stores, all within the same data set. So once you've created your data set and your data store, then you can start to move data into it. So there are a couple of ways to execute this if you, at some point, are inclined to read any of the documentation on the Healthcare API website. There are a couple of ways to do this. You can do this over a curl command via the API natively, or the case that we're highlighting here is we're using the gcloud utility, which is basically a command line utility that allows you to execute all kinds of different functions in the GCP environment. This particular one, as you can see, is specifically targeted to healthcare and what we're doing here. So we are executing healthcare, Firestore, import operation from GCS. GCS is Google Cloud Storage. And we're specifically telling it where we're sending this stuff to, so which Firestore ID. These are some of the environment variables that we'd set up in the previous step. The data set, the location, so this is the region in particular. And then finally, the actual URI of the GCS bucket. So this GCS bucket here is something that already exists. And in this bucket are a bunch of FHIR resources. And actually, if you're familiar with GSUtil, one of the other command line utilities in the GCP environment, you can actually download all the items in this bucket directly into your Cloud Shell environment, and you can look through these FHIR resources directly yourself. And why don't I just type in what that might look like? It would be something like GSUtil copy all of this stuff into your current directory. So if you actually wanted to see what some of these FHIR resources look like on disk, you can do this directly in the Cloud Shell environment and cat through them and take a look at what they look like. Okay. So the operations that are executing are in the Google land are known as LROs. They're considered long-running operations, LROs. So you can imagine if, for example, you had tens of thousands, millions of items that you wanted to import into the store, it would be an asynchronous operation. You just execute the operation. It would take some time to complete. And so there are a couple of ways that you can monitor that activity of where it is in its execution cycle. One of the ways to do that is to actually look in the console. If you go into the healthcare console, which you were using to create the data sets and data stores, once you click into a data set it'll list all the data stores in that data set. And one of the tabs that's there is operations. And in that operations tab, it'll show you all of the long-running operations that are executing against, your data set or data store. So some examples of long-running operations are two of them that we're executing here. Number one is the bulk import. So we're bulk importing a bunch of stuff from the GCS environment into the Firestore. And the other operation that's considered a long-running operation is exporting from the Firestore to BigQuery. There are a host of others. One of them that's particularly interesting is de-identification. So we have an opportunity to de-identify FHIR resources directly from an identified Firestore to a de-identified Firestore. And so that's also an operation that's considered a long-running operation. It executes asynchronously, operates against Firestores, so you can de-identify Firestores, and then DICOM stores. So for those of you who are working in the medical imaging space, we have a DICOM API, and you can store DICOM images, and then de-identify DICOM images, both the header information and the pixels in an actual DICOM image. So before you can execute the export from the Firestore to BigQuery, you first have to set up the permissions, and these commands tell you exactly how to do that. Okay. Vivian, do you have a question in the back over there? Okay. So as I was saying, these are the commands that help you execute these permissions settings. These are IAM permissions. This is how permissions are done in the GCP environment. You assign roles to basically users. In this case, this is specifically the service account for the healthcare API because it's the healthcare API that's executing this transfer into the BigQuery environment. So that account needs to get the appropriate permissions in the BigQuery environment. Specifically here, we're looking at the roles BigQuery.dataEditor and BigQuery.jobUser. Once that's done, you'll be able to go ahead and actually execute the export. So again, we're using G-Cloud environment, and what we're doing here is healthcare, Firestores, export, BigQuery, highlight the Firestore ID, the dataset ID, and the region, and then finally, we're going to tell it where to send the data to. We're specifically setting it to this particular project that we're using. And remember, the Quick Labs environment starts up all these resources for you. So it has its own project ID, et cetera. And then it creates the data set. And particularly, I had mentioned in my talk that there are two different schemas that Firestore can export into BigQuery. One of them is analytics. The other one is lossless. And in this particular case, we're exporting under the analytics schema. So once you have the operation has executed successfully, we can go ahead and move over to the BigQuery environment and take a look at what's happening there. What did we get for all of our efforts? So we're going to go into BigQuery, walk through how to do that in the console, and you can find the specific data set and tables that were created through this process. If you wanted to play around with those tables, you could just do select stars on them, and I think it's something like 40 patients were in this batch, and that's not enough. We need more. So I have some instructions here on how to get access to this larger data set. In this particular case, it's a synthetically generated data set from Cynthia. It's about 20,000 patients. And when you load it up, when you get it into your BigQuery environment, you take a look at that project HCLS testing data. You'll actually see that there's a much larger project there, a 1 million patient project, data set, I should say. And feel free to play with that if you like as well. The queries just take just a touch longer to execute. So once you're actually in the BigQuery environment and you've played around with the different databases and you've added the HCLS testing database into your environment, these queries here are written against that data set, the 20K patients lossless in this particular case. And I iterate through a bunch of these queries. As I showed in the previous session, I think it's really interesting to see the output of these queries. Like, as I mentioned, knowing what's in your data set is a really important thing for folks who are working in this space, who are building tooling in this space. And knowing what's there, what it looks like, how it's represented in the database, it's a critical piece of information. So I definitely love starting off in this area here to get this information. And also it's interesting to take a look, compare and contrast the two of them. Like, take a look at the information schema for the analytics schema and take a look at the information schema for the lossless schema. And you can page through them at your leisure and see what some of those differences look like. I kind of touched on building query generators. If you were to kind of walk down this path and be interested in writing your own query generator, this is definitely where you would start. So you would execute these queries, get back a list of all of the columns and all of the nested elements, etc. And you would use that as kind of like your primitive scaffolding to iterate over all of the items for whatever it is that you happen to be doing. Particularly if you're doing something like a patient longitudinal record. So we want to do like a patient longitudinal record in this kind of environment. So what does that mean? When I hear patient longitudinal record, I hear get me back all the things. So everything for a particular patient. And I believe in the FHIR server, there's a way to do this. I think there's an actual like endpoint, which is like get all or get everything. I can't recall off the top of my head. But this is how you would do something similar in the BigQuery environment. In a relational database environment, not even BigQuery in particular, you would have to either manually write a query that iterated over all the resources. Now recall, FHIR standard has like dozens and dozens of resources. So you can imagine a scenario where you would be writing like a multi-100 line query to get everything back from all of the resources. And that's just like a terrible thing to do. Nobody wants to do that. So I highlight a few of the different queries and I talk about the difference between column field paths and columns and what are the various data sets returned there. Interestingly, about columns, it returns the ordinal position. So knowing where the column is in the sort order in the specific table, it's also interesting. Once you've had some time playing with that information schema, the next query that I have up on the tutorial is the get all patient MRNs. And this is a particularly fun query because it gets to leverage, that very critical item, the unnest function. So this unnest function, and if you can see what will happen to the query if you just, you can play with the query. You can take out these two columns, put in a select star, and remove the unnests if you like. And then you can see what the output of that query looks like and what it returns and how it's displayed in the output. You can see it both tabularly, and I think BigQuery also has a tab where you can see it in JSON, so you can see what some of that output looks like. And what you'll quickly realize is that if you want to filter on any of the items that are in any of these nested elements, you have to pull those items out of their nesting through the unnest function. And it's the unnest function that allows you to get access to those individual items, not only for the select, but in particular the filter. And in this particular query, I put in limit 1,000 because this is operating against the 20,000 patient database. So again, feel free to take the limit out. And you can take a look and see, how long these queries take to execute on first execution. And when you're playing around in the BigQuery environment, you can see what that execution path looks like, the query plan, basically. And you can see how much data was read, how long it took to read it. And then, interestingly, if you don't change the query and you execute the query again, you'll see that it executed much quicker because the results were cached, basically. So there's this whole mechanic in database systems where you can fingerprint the actual query. And this is a trick that a lot of database systems use, is if the query hasn't changed, you can key a cache based on the query itself. And you can test this out because if you change anything in the query, then you basically invalidate the cache. And I believe that's how BigQuery more or less does what it does. So I'll sit here on this patient query for a few more minutes before moving on to the ECQM query. If anybody has any questions. What I'll do is I'll pull up the ECQM specifically so you can see what that looks like on the actual site that's dedicated to this. So this is really interesting. If you're on the technology side, perhaps, and you're interested to know what kind of queries clinicians or researchers may be interested in, but you might not have a clinical background, this is a great place to go. Take a look at what some of these items are in this ECQM library, and it really gives you a great understanding of what it is that people are looking for, so what are some of the important items that many people are interested in, and it also breaks down what those querying criteria are. So in this particular case, and the query that we're demonstrating in the Quick Labs, it's dedicated to this specific ECQM. This one is diabetes, hemoglobin A1C over a certain threshold. And from a clinical perspective, if your A1C is over this particular threshold of 9%, you're considered in the poor control category. And the particular, let's read off the description, is percentage of patients 18 to 75 years of age with diabetes who had hemoglobin A1C more than 9% during the measurement period. The initial population is 18 to 75-year-olds with diabetes with a visit during the measurement period. So if you kind of unpack these statements and you think about how you would address them in the query itself, you can kind of see why it is the query is constructed in that fashion. And let's see. I wanted to see if there was, usually tells you, I don't know if I can find it, but it tells you how they want the results. And I think it specifically said ratio somewhere. I can't find it right now. So let's step through that query and take a look at what that looks like and how I kind of went about trying to solve this problem. So I have a final query that puts all these steps together, but what I did here was I broke it out into the individual components so you can see how the individual components work in their own right, because if you look at the result of the final query, really it's just spitting out one row of numbers, but that's not particularly interesting. Like, you really want to see like what is coming out of the actual data set specifically. So this query here is, I believe it's the specific incidences of poor control, A1C over a particular threshold. So there's an interesting thing here. The interesting thing specifically is the row number over. It's the partition part. So O dot is the observation resource, and the observation resource has a date component. When was this observation observed? Issued, in this case, issued is the date here. And we want to, what we specifically want to do is we want to get the last one. So this was indicated in the query itself. And this is how you would do something like that. It's kind of like order by date limit 1 or top 1 if you were looking in thank you, if you were looking in, if you're working in various systems. But the row number over partition is kind of like the best practice on how to do that, especially when embedding that information into like a subquery, which is what we're doing here. So more interesting parts, particularly A1C hemoglobin. this is particularly how it was encoded in the Cynthia output. But it's these kinds of areas when you're working with real data, the specific coding for hemoglobin, if it's a lab code, so it would be like a LOINC code, some systems may actually report LOINC codes, and this is where you would be able to substitute the text like here for hemoglobin with a particular LOINC code specifically. Obviously, we're only interested in final observations and not preliminary observations, for example. So these were specifically the set of people who needed a little bit extra help. And then what they want to do is they want to compare that against the general population. So here I kind of broke out that item in particular, and we stepped through this query. A couple of interesting things to note I had mentioned in my talk is specifically the safe offset 0. So safe offset is a standard ANSI SQL standard library function call that specifically gets you, basically unpacks an array and gets you, I believe, the first element in it, whether or not the array is empty. And that's what the safe part of the offset is. There's another offset that's less safe and would basically error out, I think, if the array was empty. And then the other interesting piece here is, again, we are doing this text wildcard search, diabetes. You would, in a system that actually had real diagnosis codes, like ICD-10s or something like that, you would substitute that for a text search. I had mentioned this current date when you're doing a date diff for the age of the patient specifically. So birth date is in the patient's resource, the patient resource, and you're looking for patients of a certain age. This is a floating variable. It's a dynamically evaluated variable in the actual query every time you run the query. Now, if you're in an organization that's doing reporting over specific time periods, then you would need to replace current date with like a real date, so that you were deterministically getting back the same numbers every time you reran the query. Finally, we put it all together, and I kind of glossed over this really quickly last time around, so I'll give it a little bit of love this time around. It's the items at the end. Basically, we kind of step through the query, we waterfall through the query, we put all the maximum patients, the patients with problems, the full population, the maximum observed, and then we organize it in such a way that we get back just numbers. We want to get the counts returned, and then we want to execute the counts so that we can return a ratio. And that's what's happening at the bottom of the query here. And that's more or less it. Hopefully you guys were able to follow along and tinker around with some of this yourselves in the BigQuery environment. We will be here for a while, and we also have a booth in the back over there, and we have a few Googlers, myself and a bunch of others who are here. So, if you have any further questions, please don't hesitate. Thank you very much.